Welcome to the first session of remote sensing for water resource management applications. So, for this session, we are going to be looking at some of the observable parameters for water resource management when it comes to remote sensing. So, for this session, we're going to focus on three objectives. So, you must be able to understand what are the observable parameters for water resource management from the perspective of remote sensing. You must understand what are the merits and demerits of using remote sensing for water resource management, and what are some of the possible themes within remote sensing for water resource management. So these are the three objectives that will guide this session, first session. So let's look quickly to what are those perspectives that you need to understand. If you think of it clearly, if we want to observe data, we want to look at water, there are a number of things that we can quickly observe based on your understanding from previous sessions on remote sensing, aquatic remote sensing. One of the first things that comes to mind that is easily derivable from remote sensing is a chlorophyll A, which is a proxy for phytoplankton biomass within the water body. It gives the water body a distinct color, and visually it becomes easy to identify in terms of how much biomass of chlorophyll A is within the water body. And that can give us an idea of for harmful algal blooms and some other particulate matter within the system. So a visual observation can give an idea, most especially when it comes to chlorophyll A. The color in terms of the green of the chlorophyll can quickly come to mind and help us to identify the biomass of phytoplankton within the water body. Next one is water turbidity, which means how deep can we see through the water. So this can be captured with remote sensing. We can find some ways of measuring this with remote sensing. Another aspect is the dissolved organic matter, CDOM. So these can give us an idea of the kind of organic matter, the content of organic matter within the water body, giving us a visual. Since it's going to be colored, we can really see, based on visual observation, the kind of colored organic, dissolved organic matter that is within the water body. So this is one very observable parameter or property from remote sensing for water. Another one is sea surface temperature. The temperature of the surface of the water can easily be measured and can be captured with remote sensing. Another aspect is surface wind, and finally salinity, because this gives us an idea of how much salt is within the system of the water body. So all these can be captured, and so much more, because the technology keeps developing and getting better. So we can expect that there will be more opportunities to measure other parameters of the water body as more and better technology get developed. So moving on from these, clearly now becomes something to consider, that what are the advantages of using remote sensing within water resource management framework. One of the first thing that comes to mind is that there is an advantage of having a quick overview in terms of we can have a synoptic coverage, which means what we measure from remote sensing can give us a very good summary over a large area of water body. For example, if we want to look at sea surface temperature and we want to go to the field and start doing this measurement, it can be daunting. But with remote sensing, we can get a summary for a large expanse of the ocean with remote sensing without having to expend the cost that will be involved if we have to go to the field to do the measurement. And even though if we have to go to the field, if let's say we have an unlimited pot of money that we want to use to go for the field work, there is still the limitation of what we can cover. But with remote sensing, the coverage can be wide across a large, can be very detailed to a certain level for a wide area. Another potential benefit of using remote sensing in water resource management is the temporal frequency needed to capture dynamic aquatic processes. For example, if we need to look at surface wind, the regularity at which satellite passes by over a certain area can give us an idea of the dynamics of what is going on. So, since we can cover a large area, the regularity of measurement can also help us to understand the dynamic, which is one advantage that remote sensing gives us when it comes to using it in water resource management. The other advantage is that in areas that are seriously inaccessible based on the difficulty of access to the place or the challenges it poses in terms of the risk, remote sensing offers an opportunity to actually take measurement and observation from such places without incurring the risk or exposing human life to such risk in those places. So in many places that are infrequently measured or where we have very few records based on human contact, remote sensing can provide an opportunity to have data in such places. But just like it has its advantages, there are also disadvantages. One of the problem also is the temporal frequency. Some sensors only pass by every 24 hours, some every 48 hours, and so on. So with this kind of measurement, if there are some processes that needs to be observed in more details in terms of temporal details, because they don't occur over that kind of period that the repeat overpass of the satellite or the sensor will be, then we are not going to be able to find a good way of measuring them when it comes to remote sensing. So for example, if we need to measure the effect of tides and we have a satellite that only passes by every 24 hours, the satellite will only be able to capture one part of the tide movement. So unlike if it had been that we have an observation post or buoy that is placed permanently that does continuous monitoring, you can see that for some processes the temporal detail or frequency of satellite will not be adequate, but for some it might be adequate. So we have to take note which process do we want to measure. What is the temporal dynamics of that particular process before deciding whether satellite measurement or remote sensing will be adequate or not. Another challenge also for water resource management using remote sensing is that water is a dark target. So a lot of the signal that we're going to get with satellite sensors will be full of noise. So we need to spend a lot of time in reducing this noise. So any sensor that needs to be used will have to be very sensitive enough to ignore the noise and really focus on the signal that is coming from the water body. So this is one of the challenge. And the other challenge also is that this signal to noise issue is also problematic as a result of the atmosphere through which the signal will pass through. So since between 80 to 90% of the light in the signal that we're going to get to the sensor is from the atmosphere, there is need to spend a substantial amount of effort, expend a lot of effort on doing atmospheric correction. So these also makes it very difficult in getting very low, high quality satellite data or sensors data that is based on in respect to water resource management or from getting signal from water. But it doesn't mean it's impossible. It just means that we need to spend a lot of effort. We need to expend a lot of effort in atmospheric correction, and also reducing the signal to noise ratio, making sure that there is more signal than noise because of the peculiarity of water as a dark target. Also, one very challenging thing with water is that it moves. So because it's moving, observation made now, which is just an overpass, which is a kind of snapshot at a particular time, doesn't mean that that particular measurement is valid in the next few minutes or few hours, because water moves. So there is constant mixing, there is dynamism across water bodies. So this makes also using remote sensing for water, it makes it challenging unless we have constant monitoring that we can blend with remote sensing. There can be challenges with needs which will require some innovative thinking to maneuver around this limitation to make remote sensing really useful for water resource management. The other challenge is clouds. Depending on the sensor we use, cloud formation over water body is quite a normal phenomenon. So dealing with cloud cloud coverage can also be a major challenge. Also, this is a major challenge generally for remote sensing, depending on the type of sensor being used. So this is just an overview of some of the challenges and some of the benefits of using remote sensing for water resource management. I'm sure you can come up with some other challenges as you will realize some other challenges as you begin to use the remote sensing for water resource management. But generally, there are some areas where remote sensing is highly adequate, and there are some where it is suboptimal, and there are some areas where it needs to be blended with monitoring, on in-situ monitoring, to combine with remote sensing to make it adequate for water resource management. So, what are some of the areas and themes that we can adequately apply remote sensing in water resource management? One area is marine fisheries. So, monitoring of dynamics of marine fisheries for marine area protection. So if we need to do protection in terms of watching out for pollution and watching out for environmental damage, remote sensing can be highly adequate there. Animal migration. We can look at the dynamics of animal migration using remote sensing, especially if there are animals, aquatic animals that are easily observed when they move, and how when we look at the dynamics of the water that they love to migrate into. Water quality is also directly linked to eutrophication. We can measure subsidence, we can look at subsidence, coral reef health, coastal development across the coastal areas, flood hazard and sea level rises. All these different areas have clear and well understood methodology for applying remote sensing across them. So this list is not meant to be exhaustive. There are so many other areas with new sensors being developed, with new models and new technology coming out. This list is more than likely to continue to grow. But I just want to give you some few examples of thematic areas by which we can, for example, in the Niger Delta, we could be looking at subsidence in terms of using remote sensing, because there is sentinel data which we can use to look at how the land, how land is being is subsiding as a result of different human activities across the coastal areas. Water quality also, if we look at the Niger Delta, this can also be clearly seen. And also we can look at inland waters across different parts of the country. We can look at how the dynamics, the water quality is changing. Is it getting more eutrophied? Since we can use remote sensing to look at chlorophyll A, water turbidity, all these can be combined to give us an idea of water quality or monitor eutrophication across different types of water body. So this is not an exhaustive list, it's just a pointer of some of the areas in which we can use remote sensing across water resource management. So what have we gone through so far? We have looked at observable parameter for remote sensing, from remote sensing for ocean and water body monitoring. We have looked at the advantages and disadvantages of remote sensing for water resource management and monitoring, and we have also examined some of the thematic areas within water resource management when it comes to using remote sensing. So I hope you have gained something out of this, and I will see you in the next session. So see you soon.